Hey, welcome back. This is episode 17 of the Salesforce Agentforce Masterclass. Today, Agentforce for Developers, Custom LWC Components. Architecting rich, AI-driven dynamic user interfaces for autonomous agents. Let's get into it. Here's what we're covering today. The UI extensibility architecture of Agentforce, then, dynamic component rendering via Apex Action Payloads, then, real-time state sync with Lightning Message Service, LMS, then, designing agent-aware and stateless LWC components, then, security and isolation sandboxing with Lightning Web Security. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Today, we are unlocking the ultimate developer superpower, giving your Agentforce agents a visual front end. We will explore how to build and orchestrate custom Lightning Web components that render dynamically based on the Atlas reasoning engine's decisions. By the end of this session, you'll know how to pass state seamlessly between your autonomous agent and your client-side UI.
That sounds incredibly powerful. I always wondered how we move beyond simple text replies to show users interactive maps, dynamic tables, and custom checkout components inside the chat.
Welcome back, Trailblazers. Today we're diving into how you can give your Agentforce agents a visual voice. Think of Agentforce as an ultra-smart mind, but without Lightning Web components, it is operating in a dark room without a monitor. By integrating custom LWCs, you allow the Atlas reasoning engine to dynamically render stunning, interactive UIs directly inside the chat utility or record pages. This means instead of just reading text, your users can interact with custom maps, product configurations, or dynamic approval forms generated on the fly. So, how does the agent actually trigger an LWC? The secret lies in Apex Action providers that output structured JSON payloads containing UI configurations. When the Atlas engine decides to call an Apex action, that action returns custom schema data which is intercepted by the agent UI framework. This framework acts like a dynamic stage manager, reading the payload type and instantiating the corresponding LWC dynamically. It's like ordering a pizza and having the delivery driver set up the entire table and plates for you in real time. When your AI agent completes an action, the rest of the Salesforce page needs to know about it instantly. We achieve this seamless orchestration by leveraging the Lightning Message Service, or LMS, as our asynchronous communication highway. When the agent updates a customer's shopping cart or issues a refund, it publishes a message to a custom Lightning message channel. Your other on-screen LWCs subscribe to this channel, instantly refreshing their tables, charts, or progress bars without requiring a full page reload. Building LWCs for Agentforce requires a shift in how we handle component state and lifecycle. Standard LWCs assume a linear user journey, but an autonomous agent can change directions mid-conversation. To build robust components, you must design them to be stateless or defensively stateful, constantly reading context from public properties passed down by the agent container. If the user tells the agent to change the target account, your component must cleanly re-render without losing the transaction thread. What if you don't want to use the standard out-of-the-box Salesforce chat console? Enter the Headless Agentforce API, allowing you to build completely bespoke chat experiences using LWC. Think of this as ripping out the dashboard of a car and building your own custom digital display while keeping the powerful engine underneath. You use wire adapters or imperative Apex to send user prompts directly to the Agentforce runtime, then parse the response streams to build a highly custom, branded interface. When Agentforce sends back raw data, your LWC's JavaScript controller is the master chef that preps the meal. The agent might return a complex payload with nested arrays containing product lists, pricing calculations, and discount tiers. Your JavaScript controller must parse this JSON payload, handle any potential nulls, and map the data into reactive properties that feed your HTML template. Using clean array mapping and ES6 destructuring ensures your dynamic tables render smoothly without freezing the user's browser. Security is paramount when bringing AI-driven dynamic content into your Salesforce environment. With Lightning Web Security, or LWS, enabled, your custom Agentforce LWCs run in a secure sandbox. This prevents malicious scripts or unexpected payloads from accessing the global window object or leaking sensitive CRM data across namespace boundaries. It's like having a high-security vault door protecting your core Salesforce data while still allowing the AI to display beautiful, interactive interfaces in the lobby. To wrap things up, let's talk about performance optimization. Because Agentforce conversations are fast-paced, your LWCs must load and render in milliseconds. Avoid making heavy, imperative Apex calls inside your dynamic components. Instead, rely on the data already grounded and passed by the agent. Utilize the Lightning Data Service wire adapters to cache record data locally, and leverage component lazy loading to defer rendering complex UI elements until the agent actually requests them. Alright, let's wrap up. Here are the key things to remember. Agentforce agents use Apex Action JSON outputs to determine which LWC to render dynamically. LMS, Lightning Message Service, provides a decoupled, real-time message bus to synchronize agents with page layouts. Designing Stateless, defensive LWCs ensures resilience against nonlinear conversational jumps made by users. Lightning Web Security, LWS, provides the sandbox necessary to render AI-driven dynamic components safely. If this helped, hit like, it really helps the channel. Next up, Agentforce EP18, Analytics, Agent Success and ROI Dashboards. See you tomorrow.